In this video, I'm going to show you how to use significant figures during calculation. So we're first going to cover multiplication and division rules, then we're going to do addition and subtraction rules, and then we will touch on log functions. Currently, the log functions are totally unrelated to what you need to know, but we will have an acids and base unit, and they'll be useful when calculating pH. So, Chapter 1, question number 83A asks us to calculate answer the question, calculate to the correct number of significant figures. So this is a simple calculation, 9.15 divided by 4.970, and we can just plug this directly into our calculator. So when we do that, we get 1.8410. 46278. Oftentimes students will ask me, where do I round? So here is the answer to that question. Whenever you have a multiplication or a division question, you need to look at the numbers you are given and figure out how many significant figures each of those numbers has. So our first number, 9.15, has no zeros, so it only has non-zero numbers, and it has 3 of those, so it has 3 significant figures. Our second number, 4.970, has a 0, but it is a trailing 0, and there's a decimal point. So all 4 of those digits are significant, including the 0. So we have a number with 3 significant figures and a number with 4 significant figures. All you need to do is figure out which one has less significant figures. So we know that 3 is less than 4. So our answer needs to have 3 significant figures. Okay? Whenever you're looking at this, you want 3 significant figures. So we're actually going to look at the first 4 significant figures and figure out, does this 4th sig fig, is it going to force us to round this? Well, that 4th sig fig is a 1, so it's not going to affect the 4. Remember, if it's 5 or above, it gives that number a shove. So if it's 5 or above, we would have to round that 4 up, but we do not. So our answer is going to be 1.84, and that is it. We're going to do one more example. So I'm looking at 83B. We are now multiplying 3 different numbers. So our first number has no zeros, all non-zero numbers. So each of those digits is automatically significant. So it has 3 significant figures. Our second number has some leading zeros. Okay, so those are never significant. A 0 in between numbers, so that is significant. And a trailing 0 that's behind a decimal point, so that's also significant. So this has 4 significant figures, and our last number only has a leading 0, which is not significant, so it's going to have 2 significant figures. So the rule for multiplication is the exact same as it is for division. So we have 3 sig figs, 4 sig figs, and 2 sig figs. Well, 2 is a lower number than 3 and 4. So our answer needs to have 2 significant figures. When we put all 3 of these numbers in the calculator and multiply them, we get this huge number down here. So how do we round it? Well, we need 2 significant figures. So with this number, I want you to notice that it starts off with 2 digits, but they are leading zeros, so they do not count as significant figures. So we're not counting those, and then we have 1, 2, and just like we had 2 in the last problem, we have to look at that 3rd sig fig to see if it will force us to round the 2nd significant figure. In this case, it's a 5, so we will have to round that 2 to a 3. So our answer is 0.033 in this number. These are leading zeros, so they don't count as significant figures, and we have 2 sig figs. So your answer is 0.033. Significant figures are a little different when we're adding and subtracting. So I'm doing 85A, and when adding and subtracting, we are looking at place values. So the more you go to the right, the more precise our numbers are. Okay, so in this case, 2.341 is a lot more precise than 43.7 because 43.7 only goes to the tenths place. 2.341 goes all the way to the thousandths place. So when adding and subtracting, we go to the least precise number. This least precise number is our guide, and it stops at the tenths place, which means our number, our answer, is going to have to stop at the tenths place. Okay, so we are going to round this number to the tenths place. So if it's 41.359, that 5 will kick up that 3. So we will round it to 41.4, and that will be our answer. So I want you to notice our least precise number goes to the tenths place. So our answer also goes to the tenths place. Okay, it can't be any more exact than the tenths place. And that is true with addition as well. Addition is the same thing. At this point, you can stop the video and rewatch it when we do acids and bases. A quick note about significant figures in regards to logs and pH. So the pH of something is equal to the log of the concentration of H3O plus or H plus. Because it's the log, it's a base 10, so that first number is actually called a magnitude number and not counted as a significant figure. So if we have a pH of 2.314, and that's our pH, this actually just has 3 significant figures. And the first number, that 2, is not counted as a significant figure. And that's because of the base 10 property of logs.